Alright, this is a review video on the quadratic formula. We will work problems number 5, number 6, number 8, number 9, and we will discuss number 10. For the answer key to this practice review, look in the folder named Solving Quiz Review. This review began with a discussion of the discriminants. These will be in a video named Discriminant Review. We're going to look at problem number 5, then we'll look at problem number 6. So, as we're working on these, we need to remember that we have to use the quadratic formula, which means we kind of need to remember what that is. Here's the formula. I'm telling you now, this is going to be a necessary part of your quiz. This will actually be question number 1. You will need to write the quadratic formula correctly as problem 1 on your quiz. So, here we go. The first thing to remember about using the quadratic formula is that the equation must be equal to 0. We see in problem 5 that that is the case. We see in problem 6 that all of this needs to be moved to the other side in order to set this up so that we can use the quadratic formula. Let's go and work on problem number 5 first. We need to identify the A, the B, and the C. A will be in the lead coefficient. The B is going to be the coefficient on just the value of V, just the variable V, and C will be the constant. So our A is going to be equal to 1, B is going to be equal to 2, C is going to be equal to -8. I'm going to write all of that in the quadratic formula. I've written an open system of the quadratic formula, and I'm going to fill the numbers where they belong. The first part will be 2, that's the B. Here is another 2 that will be squared. The A is going to be equal to 1, the C is going to be -8, and then it'll be 2A underneath, which will be 2 times 1. What we then are going to do is to calculate the discriminant, just this section of it. 2 squared is going to give you 4. Then if we have -4 times 1 times -8, this is actually going to give us positive 32. This will combine to give us 36. This is the discriminant. Should be a 36. This 36 will go back inside the square root, goes back inside, sits behind the plus or minus, and I have -2 in the front, wrote -6, meant to have -2 there, and that's all over the value of 2. Well, we know that the value of square root of 36 is going to be square root of 36 is equal to 6. The 6 then returns to give us -2 plus or minus 6 all over 2. This will provide us 2 different results. We will have here -2 plus 6 all divided by 2. Here we will have -2 minus 6 all divided by 2. This one is going to be equal to -12 over 2, which will actually equal to -6. The first one will equal to 4 over 2, which will equal to 2. So the final result is going to be x equals to either, I should say both, 6 and 2. Those are the 2 solutions. If we look at our answer key, can't look at the answer key, I just found a mistake here, I apologize. This is not incorrect. -2 minus 6 is actually -8 over 2. This is actually going to equal to -4. So I would end up with -4, 2 as my results. Now if we were to go look at our answer key, we will see here we have -4 and 2. This is going to be the solution for problem number 5. Let's go back. As we said with problem number 6, we have two parts of the equation that need to be moved. The 6m squared needs to be moved, and the 7m needs to be moved because we want this right-hand side to be equal to 0. So let's do that. Like so. So now I see that my a value is going to equal to 8. My b value is going to equal to -7. My c value is going to equal to a +1. You have a, you have b, and you have c. We're going to take these values, put them into the quadratic formula, and see what they produce. The b is going to be -7. We have also -7 squared minus 4 times a, which is 8, multiplied to c, which is 1, and in the denominator of 2 times 8. We will take the discriminant, calculate this. We have -7 squared, which gives us 49. 49. And then -4 times 8 times 1, which gives us a -32. 49 minus 32, this is going to give us a 17. This is the discriminant, and this value returns into the quadratic formula, like so. In front of that is going to be plus or minus the now +7 divided by 16. There's nothing more to be done. The radical contains a +17, which is not simplifiable, and the value here, and the value in front, those are not divisible by the same number. This is a 1, so you can't divide that. We are simplified. Let's look at our answer key. We were looking for 7 plus or minus the square root of 17, all divided by 16. This is the response for problem number 6. Let's go back. Okay. Let's go to problem number 8. We have a quadratic that is not equal to 0. So our first job is going to be set this equal to 0. We need to subtract the 4 here. We need to subtract the 4 here. We will produce for ourselves 0 to be equal to 14 minus 4 is going to give us a 10, positive 10. We will have in front of that -6b as the variable this time, and a b squared. In this particular case, our a value is going to equal to 1, our b value is going to equal to a -6, and our c value is going to equal to 10. We will put these in the quadratic formula. So b is in the first parenthesis -6. Inside the radical, it's the number that will be squared. We have -4 times a, 1, times c, which is 10, all of that divided by 2 times the a, which is 1. Our next job is to calculate the discriminant. We have 36 from this -6 squared minus, because we have -4 times 1, which is also times 10, which gives us -40. This discriminant then will calculate to be -4. This is the discriminant. This value returns to the square root. -4 is inside. We have plus or minus. Now, minus -6 will give us a +6. we will then have a denominator of 2. We must now simplify this radical. We know that the square root of a negative 4 will produce I outside the square root of 4 on the inside, which then simplifies to 2I. This comes back into the math problem, and we write it like this. So we have, this is the second stage here, this was the first stage, we're on to the third stage of the problem. Here we have 6 plus or minus 2I all divided by 2. Now, we're done with the radical. However, we need to look at the values in the fraction. This 6 and this 2 and this 2 are all divisible by the same value. Each can be divided by 2. So we need to do that. 6 divided by 2 would give you 3, plus or minus. 2 divided by 2 would give you 1I. The denominator, 2 divided by 2, would give you 1. It's unnecessary to write these, so we could simply write x is equal to 3 plus or minus I. This is what we're looking for in the answer bank. Let's go look. Here we have the 3 plus or minus I, which is going to be the answer for number 8. Let's go back. Alright, let's move on to problem number 9. Problem number 9 is yet another quadratic which is not solved for 0. We need this negative 5 to be added to the other side. So here we're adding 5. We will add 5 to this side here. What will be left will be this. Equals 0. We will have 8a squared plus 6a plus 5. In this case, our a is equal to 8, our b is equal to 6, and our c is equal to 5. A is equal to 8, b is equal to 6, c is equal to 5. We're going to fill the quadratic formula with those values. So in this first position we'll put 6. We'll put another 6 here. That's the 6 that gets squared. Negative 4 times the a, or the 8. And then we have times the 5, which is the c. 2 times a in the denominator is 2 times 8. We will next calculate the value of the discriminant. This is going to give us 36 minus, now negative 4 times 8 is going to give us a 32. That value is also going to be multiplied times 5. These two, the 32 times the 5, is going to give us 160. And then 36 minus 160 is going to give us a negative 124. We have a discriminant of negative 124. This will go back into the quadratic formula. Negative 124. Remember, the negative will actually at some point become I in front of the radical. And all I'm doing here is completing the calculations. 16 in the denominator, negative 6 out front. So our job is to, in fact, next work with the square root of negative 124. We know first we must remove the I. So we have I times the square root of 124. Now our job is to try to simplify this square root of 124. We need to try to make it smaller on the inside. We will do that by dividing the 124 by these perfect squares. I've brought the perfect squares into the problem. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, we have 25, we have 36, 49, 64, 81, and 100. We're going to try to divide the 124 by the largest perfect square we can, and then until we get a whole number as a result. So, in preparation, I did this division. 124 divided by 100 gives us 1.24. Definitely not a whole number. Divided by 81, I get 1.5. Divided by 64, 1.9. None of these are whole numbers. I'm looking for a whole number. Divide by 49 gives you 2.5. On 36 doesn't work. 25 doesn't work. 16, 9, 4 finally works. So we know that 4, I'm missing something here, should be 31. 4, when it divides into 124, produces 31. So what we are now able to write is this. We have I. We have then the square root of 4 multiplied to the square root of 31. We know this will produce 2. The I sits behind it. The square root of 31 sits behind that. This will then return to the to the quadratic formula, and we will have the following result: -6 plus or minus 2i square root of 31, all divided by 16. Once again, as in the last problem, we notice this value is 6, this value of 2, this value of 16 are all divisible by 2. We have to do that in order to reduce this fraction. Dividing them all by 2, we will end up with -3 plus or minus 1i. You don't need to write the 1, I'm just showing you the result, times the square root of 31 all over 8. This is what our result would be here. If we look for this in the answer bank, we would see here -3 plus or minus I, or 1i, times the square root of 31, all divided by 8. This is the proper response for number 9. Let's go back. Alright, last let's look at problem 10. Number 10 is talking about a golf ball. A golf ball that is hit off of the green and flies through the air and lands once again on the ground. The flight of the golf ball is measured in yards and is given as g of t is equal to -t squared plus t, 12t, and t is in seconds. After how many seconds will this golf ball hit the fairway? Here's a small drawing of the fairway and the golf ball. What it wants to know, after how many seconds will the golf ball hit the fairway? Well, it's hit, and the pathway will fly up as time moves forward. More time is passing, and eventually at some point it will hit the fairway again, and at this point the height will be equal to 0. That's an important fact. The height is equal to 0 here, h is equals to 0, but this is the one where it again lands. So we want to know at what point, at what time will h equal to 0. If we take the equation given in the math problem and write it outside of the words, we have g of t is equal to -t squared plus 12t. Well, we want to know when this part is equal to 0. So now we have 0 is equal to negative t squared plus 12t. This is pretty much a quadratic formula as before. The only part that's missing is the value of c. We can supply that with plus 0. I just paused and gave myself a little more workspace here. So, this is the quadratic we're actually working to solve. We want to know when does it equal to 0, and this is the flight pattern, or the pattern that the equation that tells us the pattern of flight. So let's set up the quadratic equation. So we know that a is equal to -1, we know b is equal to 12, and c is going to equal to 0. So my b is going to be 12 here, 12 here. My a is going to be equal to -1, c is equal to 0, that's kind of important, and then 2 times a is going to be equal to -1 again. When we calculate the discriminant in this particular case, we will have 12 squared is going to be 144, minus, I actually should wait to do that, I have -4 times -1, giving a positive 4, but you have positive 4, which is then multiplied by 0. This part here will become 0. Therefore, the discriminant is going to be simply 144. This is the discriminant. This discriminant then needs to return to the math problem. I will have square root 144 behind the plus or minus, and I will have -12 in front. All of that will be divided by -2. I'm going to run into my drawing here, so I'm going to continue this math here. We will have the next stage here. We have stage 1, we have stage 2, we have stage 3. We should, I don't know, sometimes it's helpful to mark the stages so we keep track of where we actually are. Alright, so simplifying this square root of 144, we know the square root of 144 is going to be 12. So we have now plus or minus 12. In front of that, we have the -12, and all of that will be divided by a -2. This is going to produce for us 2 results. On the one hand, we will have -12 minus 12 all over -2. We will have, in this case, -24 divided by -2. This is going to equal to positive 12. On the other side, we will have -12 plus 12, all divided by -2. -12 plus 12 is going to be 0 divided by -2, which just produces 0. So, these two values are the responses that we got from the quadratic formula. What does this mean in terms of the picture? Remember that t is in seconds. Wrote on top of that. T is in seconds. So this would be 12 seconds and 0 seconds, which makes some sense. Before the ball is hit, we have 0 seconds. But when the ball landed, as time moved forward, seconds are passing, the ball actually lands at 12 seconds. Right here. And that's what we wanted to know. Let's look at our answer bank. And in fact, here we do have 12 seconds as the answer for number 10. Thank you for